Hello. In the previous lecture, we were discussing something regarding connectedness, and I left you with a few questions. So in today's lecture, we are going to finish the questions, and then we'll try to see what we can do further. In next sessions, you'll find that we'll be starting with complex analysis, that is more on the grounds of more you can say complex functions in general. Okay. And we may also give a brief lecture. I may also give a brief lecture on complex analysis sequences. However, they are not that directly applicable here. And but still, one lecture probably on sequence and series on having some complex in C basically. Okay, so sequence and series in C would be another lecture. But more importantly, you need to focus on something called as analytic functions. Okay, so if you're attempting for any competitive examinations, most of amount of questions are asked from analysis side. Okay, so complex analysis, basically by that I mean limits, continuity, analytic functions, integrals, Cauchy-Riemann conditions, Lavallee's theorem, and so on and so forth, Picard's theorem. So there are different things. So we're going to start with that. But today, let us do a few questions where I left you with. So basically, we were discussing previously connected sets, and we also discussed some other topological terms like open sets. And we actually told that a set which is open and connected both is called as the domain. Is called as the domain. So this is something that we have already discussed. And most possibly, I left you with a few questions to attempt. And one of them was, I think, just give me a minute. One of them was that whether this particular domain forms a, this particular set forms a domain or not. So I think this was the question, that if I say that there is a set S1, let's say, and that is Z belongs to C, such that imaginary part of Z modulus is less than real part of Z modulus, then does it form a domain or not? Okay, so does it form a domain or not? So how to go about it? See, if I'm writing that Z is, let's say, X plus iota Y, it implies what? It implies simply that imaginary part of Z modulus is less than real part of Z modulus. It implies what? It implies that Y modulus is less than modulus of X. And what you can do for all the four, like what you can do is, let's say, for all of these four things. So let's say this is a first coordinate, second quadrant, third quadrant, and fourth quadrant. Uh, you can write. See, in the first quadrant, you know that y is positive and x is also positive. So in first quadrant, both x and y are positive, and this particular equation would then imply that y is less than x. In the second quadrant, you know that your y is greater than 0, but your x is less than 0. When your x is less than 0, then modulus of y would be simply y, but x would be minus of x. Third quadrant, you know that your y is also negative and your x is also negative, which implies you're talking about minus y less than minus x. And in the fourth quadrant, this equation, please do remember this equation, you don't have to forget. For the fourth quadrant, your y is negative, but your x is positive. So here you can write y modulus is y, and sorry, y modulus is minus y, and x modulus is simply x. So in the first quadrant, you have to think about what is the region y less than x. In the second quadrant, you have to think what is the region y less than minus x. In third quadrant, you have to think about what is the region which is y greater than x. And in the fourth quadrant, you have to think about region y greater than minus x. I hope it is clear. So basically, you just try to make, I'm going to make a little bit of, just to give you an idea, I'll make one line which is y equals to x, and another line which is y is equal to minus x. So this line is simply y is equal to minus x, and this line is simply y is equal to x. Now you see, if these two are the lines, And if I'm talking of y less than x, so in first quadrant, I have to shade the region which is y less than x. So this is the region which I will call as y less than x. And please remember, I'm not including this line. Okay, so I'm not including this line. This line is not included. Okay. What would be the region y less than minus x? So this is y minus x. So y less than minus x would be this region. In the second quadrant, we have to mark the region y less than minus x. Okay. If I say y greater than x in the third quadrant, so y is equals to x is this line, and y greater than x would then mean this region. Okay. And the fourth quadrant is, y greater than minus x, so this would be this region. Okay, so this is how you can define your this region. Now, clearly, this region is not connected. See why? You can clearly see if I take 1 point here and 1 point here, I cannot join by any means without leaving these region. Basically, because see, this black you are seeing, this is not included in the region. So basically, we have not included the boundary in the region. Had I included boundary in the region, then there was this pass from where you could have created a path connectedness and you could have created this path. You have created a path connectedness between the 2 points. Had it been the like, had you taken these two lines, that is y equals to x and y equal to minus x also. So for example, if I take equal to, then this would have become a connected region. But because these two lines are not there now, you cannot, whenever you have to see here path connectedness. So here you can say that path connectedness is connectedness. So basically, if I want to make a path connecting these 2 points, I have to leave this region. Because if I make anyway, so I'll have to leave this region. Or this also internally, if I want to move, then I should have this point included in the region. This point is not included in the region. So clearly, it implies that this is not a connected set. And since it is not a connected set, it implies what? It implies it is not a domain. It is not a domain. Now, had you done imaginary part of z modulus less than equal to real part of z modulus, then also the problem would have been, now you see, now it implies what? It implies that you would include this reason. So this will become a connected reason. That is not a problem. Now you have to include these lines also. So when you include these lines and this area now, this region, sorry, and this region, now you take any 2 points. Now you can connect those 2 points without going out to the region. So this is a connected, connected, you can say set, or it is a connected set. If I'm taking imaginary part of z, modulus is less than equal to real part of z of modulus. This is a connected set, but this is not open. Now, because it includes the boundary also, this is not open. So again, it will not qualify the definition of domain. Okay. So now let us do a few other things. Let's say another question I gave you was third question. I think if you remember in the last lecture we were doing it. So if you have this kind of set, so let's say set is this where z belongs to C, such that z plus iota a modulus is less than z minus a modulus for some a greater than 0. So if you have this kind of thing, then what to do? So I'll write z plus iota a less than z minus a modulus. Just think about it. Just take x, z is equal to x plus iota. So what it will give you? It will give you x plus x square plus y plus a whole square less than x minus a whole square and plus y square. And then you can do it a little bit of mathematics here. I think it will be easy for you to do here. So it will give you 2ay here, some plus y square less than x square minus 2ax plus a square and then plus y square. So y square cancels y square, x square cancels x square, a square cancels a square, and you can clearly write that y is less than minus 6. Now y less than minus 6, you know, this is how you can draw your y is equal to minus x. So this is how you can draw your y is equal to minus x. And if you're doing y less than minus x, so this would be your region y less than minus x. So this is your region y less than, y less than minus x. Clearly, this is an open set, and one can clearly find that this is also connected. So this forms a domain, no issues. This forms a domain. Okay, so all these things are easier to verify. I think these are easy things to do in your exams also. Okay, so this thing, I think we have done already, all these things. So I gave you this homework. Now let us start with, let us do a few more questions on domain. Then we'll move on to sequence in the next lecture. What do you think about this region? So let's say, if I say that I'm talking about a region where your z belongs to C, such that real part of z is not equal to 0. So what does this region mean? This region, if you draw, I mean, right now I'm just using word region. Does it form a domain or not? Okay, does it form a domain or not? So if I use this region, what is real part of z not equal to 0? So just think, what is real part z equal to 0? So real part z equal to 0 means we are talking of y-axis. So we say, it is being said that we are talking of a region where you do not have this axis inclusion. So I'll simply delete this thing. So I'll make it in a dashed way. So basically we are not including this axis. And what we are doing, we are talking of this region, real part of z not equal to 0 means anything, but it should not contain the y-axis. So this shaded region, whatever I've made, okay, but we are not supposed to include the y-axis. Now point, see, if I take any point here, and if I take, let's say, any point here, if I want to join through any connected line, any polygonal line, sorry, I will have to cross this y-axis, and y-axis is not contained in the region. So therefore I can write that this region is not, or this is not a connected set. Okay, this is not a connected set. However, it is open. It is open in the sense that it can be expressed as the union of two open intervals. But the point is this, but this is not connected. Okay. It is not connected, rather you can say it is unbounded as well. It implies, it implies that it cannot form a domain. It cannot form a domain. For domain to be formed, you should understand, you should have a set which is connected as well as open. Now let us consider another domain. Let us consider another question, and let us see whether it forms a domain or not. So let's say if I'm talking of something like z belongs to C and imaginary part z is greater than equal to 1. What do you think about this particular thing? So if I'm saying imaginary part z equal to 1 means I'm talking of y greater than 1. And if I'm talking of y greater than 1, let me draw this particular thing. So always remember, in complex analysis, if you have this habit of drawing the regions, then you will be at a better understanding level. See, that is why I have spent some initial lectures on all these things. So it is y is equal to 1, and I'm trying to now draw y greater than 1. So what would be y greater than 1? This would be my y greater than 1. So this is y greater than 1. Clearly, this is an open set, as well as connected. However, boundedness is not there, but this is not this is unbounded set. But overall, since it is open as well as connected, I can write that this forms a domain. This forms a domain clearly. What do you think about this? Let's say if I'm talking of all those complex numbers, such that imaginary part of z is less than modulus of z minus 1 whole square. What do you think about this? Whether this forms a domain or not? So what do we mean if I say imaginary part is less than this? So it means x minus 1 whole square here plus y square. Okay, what is z minus 1? If you write z is equal to x plus iota y, then clearly z minus 1 would be simply x minus 1 plus iota y. And if I take a modulus and then square it up, then this will give me this. And you know that y is then less than x square plus y square minus 2x and plus 1. And so you know that this is x minus y whole square plus y square. So I can write y minus 1 by 2 whole square. And then since I have written something like this, so the sign is here, so it will be like 1 over 4 here. So I think this is what? This is equation of a circle, but this lies exterior to the circle. So this is exterior to a circle centered at 1 comma 1 by 2 and radius 1 by 2. So what I have to do, I have to make a circle which is centered at 1 comma 1 by 2. So let's say 1 comma 1 by 2 is this with a radius of 1 by 2. So this is how it is. And we don't have to see the interior region. We have to see exterior because greater than sign is there. So this region I'm talking about. I'm talking about this region. What do you think that this region is? This region is clearly open as well as connected. So therefore, this forms a domain. This forms a domain. This is both open and connected. However, again, think that this is a think about it. This is an unbounded region. So basically, this region would be called as domain precisely. Okay, so now last question, or possibly a few more questions I would give, and then we'll start a little bit about sequences in the next lecture. What do you think about this? All z belongs to complex number such that principal argument of z lies between pi by 4 and 0, and both included. Okay, so both are included. So if you do this, you know that if I'm saying the principal argument z is lying between 0 and pi by 4, it implies that tan inverse y over x lies between pi by 4 and 0, because you know that whenever argument is lying between 0 and principal argument is between 0 and pi by 2, we are talking of the first quadrant, and in the first quadrant the principal argument is simply given by tan inverse y over x. So this gives me y over x is less than equal to 1, greater than equal to 0. It implies that y is less than equal to x and greater than equal to 0. Now what this set is connected. Clearly it is connected. See, it has got no problem with connectedness. You can visualize it by making a graph of it. So basically a little bit of understanding you have now about graphs. So this, sorry. Okay, this is y equals to x. And if you are making y less than x, so what would be less than y less than x? This would be y less than x. Okay, but y is also to be greater than 0. So I cannot include this area, but this is how it is. So this, you know that this is connected. You can clearly see that this is connected, no issues. And we have to include this also, by the way. So y has to be positive and y must be less than 0. So this is how you're going to make it. Okay, so below this axis, you know that y is negative here. So that is a problem. Okay, So in any way, this is connected, but this is certainly not open. See, this is a closed set. Since it contains the boundary points also, is closed. So therefore, this given set does not form a domain. So I hope it is clear till now. So whenever such questions have come, or anytime you see all these questions, you can do it on your own. I feel now these are not difficult questions in general. You can do it on your own. One question from, I think, a little bit from a slightly deviated topic, and that's an easy question, although. But let me ask you. Let's see if you are able to do it or you're not able to do it. It's an easy question, not that difficult, but let's see if you can do it. See, at times you should be also aware of complex numbers also. Okay, so don't forget that this is an easy zone, but you don't have to make any mistake while doing the question. I'm just giving you a question. Try to solve it. Let Z1 and Z2 be two distinct complex numbers. Be two distinct complex numbers. Okay, so I hope you got the point. This point is clear. So let Z1 and Z2 be two complex numbers such that modulus of Z1 is equal to modulus of Z2 is equals to 1, and Z1 plus Z2 is equals to 1. Then the triangle in the complex plane with vertices Z1, Z2 and -1 form what? Do they form an isosceles triangle? Do they form a right angle triangle? Do they form an obtuse angle triangle? Or do they form an equilateral triangle? So let us think about it. So what kind of triangle would be formed? See, such questions you have to do with the basic sense of understanding, a basic understanding only. So if you are doing it, let's say, let Z1 be equal to something. Let's say Z1 is X plus iota Y. Let's say Z1 is, let's say, A plus iota B. Now, what would be Z2? There is another possibility. You can write A1, B1, and Z2 you can write A2, B2. But already it is given that Z1 plus Z2 equal to 1. It implies Z2 will be equals to what? 1 minus A minus iota. Now, what is given to us? It has been given to us that Z1 modulus is equal to Z2 modulus, which gives us an understanding that A square plus B square is equal to 1 minus A whole square plus B square. And this tells us that twice A is equals to 1 and A is equal to 1 over 2. And if I take A is equal to 1 by 2 and I use this condition, any of the condition, let's say want Z1 equal to 1, what do I get? I can get it by easily I can get that B is equal to plus minus root over 3 by 2. See how we know that modulus Z1 is equals to what? Root over A square plus B square. So this is A square plus B square equal to 1. A already you know this is 1 by 2. So it is 1 by 4 plus B square. So B will be plus minus. So basically I can write my Z1 as simply 1 upon 2 plus root over 3 upon 2 iota. And what would be my Z2? My Z2 would be simply, what is 1 minus A? 1 minus A would be again this, and minus root over. If I'm not wrong, I hope this is clear. Just think about it. I've done nothing, just use the, what you can say, equations only. Okay. So basically these will carry opposite signs. If you are taking negative here, then you take positive here. And I think this is clear. So Z1 is this, Z2 is this. And another thing he's telling that the question is telling that another vertex is -1. And now we really want to know what kind of triangle does it form. So does it form an obtuse angle triangle? Does it form a right angle triangle? Does it form an equilateral triangle or isosceles triangle? So all we need to see is what is Z1 minus Z2 mod. So what is Z1 minus Z2 mod? It is simply root over 3 iota mod, and which is certainly equals to root over 3. What is Z1 minus minus 1? So the Z1 minus minus 1 would be Z1 plus 1. Okay, so Z1 minus minus 1 is Z1 plus 1. So it is equals to 1 plus root over, sorry, 1 plus 1 by 2, so which is 3 by 2, plus root 3 by 2 iota modulus, and which is certainly root over 9 over 4, plus 3 over 4, which is again simply root over 3. And if you take Z2 minus minus 1, which is Z2 plus 1 modulus, it is also again 3 upon 2 minus of root over 3 upon 2 iota modulus, which is again simply root over 3. It does prove a point that all the three sides of the triangle are equal. All the three sides of the triangle are equal. It implies what? It implies we are talking of an equilateral triangle. We are talking of an equilateral triangle. So this is how you would do things. I hope you must have learned a little bit about domain in this lecture. Anywhere, if I have made any mistake, please try to tell me in comment section, and please try to encourage this initiative of freely trying to, this initiative is all about freely educating people. So kindly let others know about this initiative. Till then, take care. Bye-bye.